So before I answer questions from the Can You Do 6, I want to clarify some things on box plots that I think are worth talking about that may help some of you guys. And where I want to start is...
Teachers, we are now ready for juniors with the last name M.
Oh.
Once again, juniors, last name M, send them on down to get their pictures. And if you have any freshmen or sophomores who did not get their picture taken yesterday, send them down as well.
Annoying. So annoying. Just thought I'd let you know. Okay, so start up here on this box plot that we drew last time. Okay? Something that we talked about, but that I don't think I went over enough, Vincent, please stop talking, is that from the minimum to quartile 1 is 25% of your data. And from the quartile 1 to the median is 25, 25, 25. Because your box plot is supposed to represent your entire distribution, your entire data set. Is this making a little bit of sense? Now, one thing that I want to clarify is, notice your middle 50%. This is not cut in half. So we need to have some kind of understanding how this section can be 25% of the data, but also this section is 25% of the data and they're different sizes. So how can they both be 25% of the data when one is so much smaller than the other? Does this question that I'm asking make sense? Okay, so I wanted to make sure that the answer to that was clear. So to answer that, let's go down to your Berry Bonds data. So the Berry Bonds data actually gives us data values that we can look at. And we talked about last time how if you compare the left-hand side of your data set to the right-hand side of your data set, I'm just trying to find, there it is. You can tell the shape of the distribution because the length of the different sides is telling you about spread. So the bottom half of the data contains how many observations were in this? 21. So this bottom half has 10 of Berry Bonds season. So this green line has 10 of the seasons that Berry Bonds played. And this purple line has 10 of the seasons that Berry Bonds played. But the reason that they're different lengths is because the data is more spread out. So if you look from the first half of the data, the home runs range from 16 to 34. So the total separation between the lowest and highest number of home runs is only 18 home runs. But then he had some seasons where he scored a lot of home runs or hit a lot of home runs. And so this data is much more spread out. It goes from 34 home runs all the way to 73 because he had that one season that was really unusual. So the spread of the right-hand side of the data is 39 home runs. So the length of the different parts of your box plot tells you how spread out the data is. So in this particular box plot, the reason why this 25% of the data is so much bigger than this is because these values are more spread out. Is that making a little bit of sense? When I say 25% of the data, the other thing that I want to mention is that means observations. So when we say this is the middle 50% of the data, what we really mean is this is the middle 50% or the middle half of the observations. So when we say data, I want you to be thinking observations. So there are 10, well, excluding the median, there are 10 observations between the quartiles, which would be 50%. So hopefully that discussion helps a little bit with questions like this check for understanding. Because unfortunately, when you get a box plot question, they are more like this. It's not a simple, what is the third quartile of this distribution? It's one of these really long ones where you need to go through and figure out whether each one of the statements is true or false, which is what you saw reflected in your can you do if you were able to do it, or if you did it. So on your can you do, you had, I think, 3 multiple choice. And all of your multiple choice options are not these easy, straightforward questions about box plots. They're actually pretty involved and require you to really know what you're looking at when you see a box plot. One of the most important questions from your can you do was this question about these 2 box plots that have there's no context. They just give you 2 different box plots and ask you questions. And one thing that is super important to know is when you get a box plot, you have no idea how many observations are in the box plot. So it is very common to think, well, this data set is smaller than this data set because this data set, this box plot's so short, and this box plot is a lot longer, so this probably has more data than that one. That's not the case. These both represent 100% of the data. The different sizes represent spread. So down here on the statement 2, where it says box A contains more data than box B, well, it looks like it does because box A, the box in the box plot, is longer than the box in B, but that only means it's more spread out. Set A could have had 10 observations and set B could have had 100 observations, but there's no way for us to know because it's like a histogram. It doesn't give us any information about specific values. It gives us information about important points in the data set, like the min, the max, the quartiles, the medians. Does that help a little bit on this box plot situation? So now that I've gone through that clarification, I think I'm just going to let the video run. So distance learners, if you don't have any questions on this, you can stop now. But just in case, if you guys have questions, I think I'm just going to keep recording so that if they have the same questions, they can hear. So do you guys have any questions from box plots? Tiara.
But when you're looking at outliers and then you like calculate and you see the outliers.
So yes, great question. So what Tiara is asking about is if you calculate that there are outliers in the data set and it turns out that the minimum number is an outlier, do you adjust the data values so that you can make your box plot? And the answer is yes. And a really good example of that is your Magna St. George problem in the notes. So in the Magna St. George problem, you had an outlier on the lower end. So you make 45 the outlier, and then the next data value, 51, becomes your minimum. Same with the upper outlier. And they will never give you a problem where you don't know what the next value you should use is. Like they'll never give you only 5 numbers and then one of them ends up being an outlier, because then there would be no way for you to graph it because you need to know that next number in order to make the graph. Does that help a little bit? So if you go through any of the problems where you actually had outliers, you will see that they gave you enough information to know what should you use instead of the outlier. Other questions? I'm just waiting in case you guys need to like look through or anything. I'm not trying to make you uncomfortable. Or maybe I am. Yeah, babe.
For comparing the distributions for spread, I noticed in the videos you have in the description for the spread with the outliers and the without the outliers. Should I be doing that in every one of the spread with distributions?
So describing distributions is one of those things where there's really no black and white. So an AP reader knows that when you describe distributions, there's so many elements that you can describe that what they're really looking for when you just compare two distributions is, are you making a comparative statement? Like, are you using bigger than or less than? And are you hitting most of the elements? So they're looking that you hit 3 out of the 4 SOX elements. So as long as what you use is correct, you usually get full credit. So the answer to that is, if that makes sense to you, if you have the time and it makes sense to you to compare what the spread would be with the outliers and without the outliers, then you can do that and there's no harm. But if you don't have time and all you can do is look at the range, I think that I would lean toward leaving the outliers out. I did both because I was unsure what I should use, so I used both. Does that make sense? So really, I know that that's not the best answer, but you remember all of the things that you should say, and you say as many things as you can in the time that you have. And if you do that, then you will hit all of the elements that you need to hit and get full credit. And typically, as long as what you're writing down is accurate, you don't get marked off. So if you did range and included the outlier, you wouldn't lose points for that as long as that range was accurate, like the numbers you used was right. But somebody next to you, like Daniel, could leave the outliers out and still get full credit just like you because his range without the outliers is right. So I know that that's not a very black and white, straightforward answer, but hopefully that helps give you guys some relief that you have a little bit of freedom in what you can write when describing spread. Center, you don't have freedom. You should use the median. If they ever give you box plots, just use the median always. But spread, typically you'll use IQR, even if one of them is roughly symmetric. Like this one's roughly symmetric, but these ones aren't. So you're going to want to compare IQR on all of those.
We are now ready for juniors with the last name of N through P. Once again, juniors, last name N through P. Send them down to get their pictures taken.
The one other thing that I wanted to say in regards to Cyrus's question is, when I grade you on your test, I grade all 4, and all AP teachers grade all 4, so shape, center, spread, outliers, because we're trying to give you the practice of doing all of them, and that will ensure that you get full credit on the exam, even though on the exam, they're mostly looking that you get at least 3 out of the 4 and make a comparative statement. All AP teachers push you to do all 4 so that when you get to the exam and you're short on time, you can quickly write down as much as you can. Other questions from Boxplots? The notes or the can you do? So I